Hello everyone and welcome back to PostNetwork Academy. So whether you are diving into data science, artificial intelligence or machine learning, understanding probability distribution is essential. And today we will explore one of the most important ones, that is the binomial distribution. So without further delay, let's get started. So first of all, we will understand binomial probability function. So you can see that a binomial probability function is given by probability of random variable x, that is for value k, and k, that is nck, p raise k, 1 minus p raise n minus k. So let us understand each component. So where n is total number of trials, k is number of successes, and p probability of success in each trial, for each trial or in each trial, remember. And nk, that is the binomial coefficient. Let us break it step by step. So binomial coefficient counts the number of ways to choose k successes from n trials. So if there are 10 trials and if you choose k 4, so you will get number of ways, that means 10c4, 10c4, that means factorial 10 upon factorial 4 factorial 6. The term p raise k represents the probability of exactly k successes, and the term n minus k, basically 1 minus p raise n minus k, that accounts for the probability of remaining n minus k failures. So you can see that there are k successes and n minus k remaining failures. So if there are 10 trials, if n is equal to 10, n is 10 and k is equal to 4, so failures n minus k would be 6. So multiplying these terms together, that gives the probability of observing exactly k successes in n trials. Now let us take an example. So suppose we have a fair coin, and fair coin means the probability of getting head or tail, that is 0.5, and flip it 3 times. What is the probability of getting exactly 2 heads? So that means k is equal to 2, and if you plug the values, so that means binomial coefficient is 3, probability you will compute for x is equal to 2, so 3 into 0.5 square into 0.5 to raise 1, that would be 0.375. Now see that we have learned binomial probability function. Now we will understand binomial distribution. So a random, you can say that a discrete random variable x is said to follow binomial distribution with parameters n and p, that means number of trials and probability of success in each trial, if it assumes only a finite number of non-negative integers. That means x should be 0 to n, not minus 1 minus 2. This we cannot take the values of n. And its probability mass function, because that is a discrete probability distribution, so we will use probability mass function term. So p x is equal to x, nx p raise x, q raise n minus x, where q is 1 minus p. Basically here Q is 1 minus P. Where N is number of independent trials, X is number of successes in N trials, P is the probability of success in each trial. Remember, P is the probability of success in each trial. And what is X? X is number of successes in N trials. And Q is the probability of failure in each trial. So let us see some properties of binomial distribution. So the binomial distribution is a probability distribution of the sum of n independent Bernoulli variates. So if Bernoulli variates are x1, x2, x3, xn, so their sum will follow binomial distribution. This is the plus x3, so that will follow binomial distribution. We will write like this one, NP. Binomial distribution. We will discuss again in future videos. So if X is a binomially distributed random variable with parameters n and p, then we may write it X following binomial distribution having two parameters n and p. And this is the most important property. If X and Y are two binomially distributed independent random variables with parameters n1 and p1, that means X following n1 p and Y that is following n2 p. So their sum also follows a binomial distribution with parameters n1 plus n2. But if probability of success is not the same for two random variables, this property does not hold. So that means X plus Y will follow n1 plus n2 here and probability would be same. But if probabilities are different, so this property will not hold. Now let us solve some questions. So an unbiased coin is tossed 6 times. Find the probability of exactly 3 hits, less than 3 hits, more than 3 hits, at most 3 hits, at least 3 hits, more than 6 hits. So let us start. Here number of tiles we will remember, that is n is equal to 6, and the probability of success, that is n bar, so probability of success would be 1 upon 2. Probability of failure again 1 upon 6. And let x be the number of successes in n trials. So first question, binomial probability distribution is here. So exactly 3 hits. That means you will keep the value of x is 3. And here 6c3, that is, and here 1 upon 6. So that will become 20 upon 64, that would be 5 upon 6. Here it has become because see that here 6 upon 6 3, 6 is 3, here 1 upon 2 3 and 1 upon 2 3, and that's why it has become 1 upon 2 raised 6 2, so 5 upon 16. So very easy questions. Less than 3 hits, that means you will use for as p is equal to 0, p is equal to 1, p is equal to 2. So p is equal to 0 means again here 6c0, that term, here 6c1, here it would be always the same because 1 upon 2 here, that is x, that means 3, and 1 upon 2, that is n minus x, so 6 minus 3. So this term will always be same. So this one 6c1 and 6c2, and if we add all the terms, we will get 11 upon 32. Let us see more than 3 heads. That means x is equal to 4, x is equal to 5, and x is equal to 3. And I am leaving on you that how you calculate. Just there is a hint that here what will happen. Here 6 C4 for this one. Here 6 C5 and here 6 C6. So you just as you multiply, you will, and just you will multiply them it by 1 upon 2 raised 6. You will get all the terms and you can add. Let us see another question. At most 3 heads. That means less than or equal to. So 0, 1, 2 and 3. Again you will add all the terms. Here 6C0, 6C1 and so on. You will add after multiplication of 1 upon 2, 6, and you will get the result 21 upon 32. At least 3 head. That means you will subtract at most 3 heads. Just 1 minus p less than is 3. So you will get here. More than 6 heads, that is impossible event. Right? More than 6 heads you cannot get. So hope you have understood binomial distribution. In upcoming videos, I will explore more about binomial distribution, more numericals on binomial distribution, and also I will show you how to understand machine learning and AI concepts using binomial distribution, like logistic regression and generalized linear models that are, you can say that, foundation for machine learning algorithm. So hope you have understood, and you will also support me. You will visit website, you will subscribe my YouTube channel, you will follow my Facebook page and also LinkedIn page. So hope you will support me. Thanks for watching the video.